Hola, SAP developers. Before we start, I just want to let you know to feel free to drop us your questions on the chat window. I'll be monitoring it, and we will leave the questions for the end of the session. Welcome to the third session of the integration tag for today. This is a session that I'm particularly really looking forward to. It's all about CloudEvents. Today, I have my colleague Klaus, who's an active contributor in the CloudEvents project. And he will be sharing with us what CloudEvents is, and also we will learn about xRegistry, which is another initiative part of the CloudEvents project. Without any further delay, hola Klaus, over to you.
Yep. Hello and welcome. I'm Klaus. I'm working as a development architect at SAP. And today I'll talk a bit about CloudEvents. My PowerPoint is very slow. Let me see. Okay, so after a short introduction, I will give a bit of background on events and computing in general, also with my personal history of events. Then I'll dive into CloudEvents in specific and give an outlook on xRegistry, which is something we are working on very actively currently in the community. And I'll close this session then with a few pointers to where you can get more information. So before we get started with the actual session, I'd just like to give you this disclaimer that I'm sometimes wearing two hats in this session. One is the SAP hat, of course, but on the other hand, there's also my community hat, as Antonio mentioned, that I'm also contributor and even maintainer in the CloudEvents project, and so I also just like to spread the word about CloudEvents as such. And sometimes I'll do a bit of advertising also for the community. And actually, that's one of those slides where I do this. So the CloudEvents project is actually run by the Cloud Native Computing Foundation, the CNCF. This is again under the umbrella of the Linux Foundation. We started doing this in the serverless working group at the CNCF in late 2017, and it soon became a project. And later in 2019, we had version 1 after a lot of discussions about the specification. And even this year, so 5 years later, then the project graduated, which is the final stage or the highest status of a project at CNCF, which means that it is by now mature and has also adopters. And nevertheless, there's still an ongoing effort, so the work isn't finished at all yet. So there have been a lot of detailed improvements, sometimes just in wordings in the spec, sometimes additional protocol bindings have been added, and I'll explain protocol bindings later. We have libraries, so SDKs you could use in various programming languages there, and even a complete SQL dialect has been specified to filter CloudEvents. There are also a few in progress, so draft specifications around pagination and for event subscriptions. And of course, and that's something I'll mention a bit more in the end, is xRegistry, which was motivated by the story around event discovery. But let's get back to events in general, events in computing, and how this started for me. Quite some time ago, in the last century, I think, I started my programming journey with this computer. It was actually my dad's computer, but I quickly wanted to find out how to do more with this, how to write programs. And then, of course, I saw those UIs that were available already on that machine. I wanted to do this too. And I was wondering how to do this. Do I have to build all this drawing and rendering on my own and all the I/O handling and so on? But luckily, no. There was this graphical environment manager on this operating system, and you could, of course, apart from all the other functionalities like rendering and the UI and so on, you could also let it notify you when something happened in your UI. And this is actually already quite similar to what we do with CloudEvents these days, in some regards at least. So you can subscribe to events, you could say. This flags parameter here is a bit mask where you can select which events you want to get notified, which of those should wake up your own code. And so that was, for me, the first time I was confronted with this eventing concept inside computer programming. And if you're interested in the Atari and want to, just because of thinking of those old days, play with this a bit more, there's actually a nice open source project I used also to do that screenshot on the slide before. But now let's get a bit more in today's eventing world. And start maybe with what we think of when we talk about events, also in the CloudEvents community. So this looks very abstract, but it's a nice mental model if you think of events. So usually you have something we call an occurrence. Something occurred to something, the subject of the event, you could say. So this subject changes usually its state from old to new, or at some point in time, the state is just red, and that's then the new state. And like in the example before, I mean, for example, if a menu item or was selected or a keyboard was used, then that was the occurrence. And in the SAP context, of course, it's more about things like business objects, an order being created, things like this. And now we are getting to the event. So if there is a producer that observes this occurrence, then this producer might take that data and describe this occurrence and all the necessary details around this occurrence and put this into a data record. And that's actually how we in the CloudEvents group also defined an event. An event is a data record describing an occurrence. And now with this data record, of course, consumers can work and act upon those. Here's just a single consumer on this picture, but of course it could also be multiple. And that's actually already one of the benefits of events, because events decouple the producer from the consumer or multiple consumers. And you could also think of this, don't call us, we'll call you, from the operating system. You don't have to call into the system or into your cloud services to understand if something has changed, to poll them, for example. You can get notified when something happens. And all this is, of course, also very useful in the context of asynchronous processing. If you emit an event and after that, you don't have to care about the subsequent activities anymore, for example, that facilitates asynchronous processing. Or if you're in an event loop and just react on incoming events, that's also can also very nicely be used for asynchronous processing. But in distributed systems, so more the world of nowadays, that comes also with quite a few challenges. So if you see our producer would be here on the lower left, that emits an event, it usually gets transmitted over the network, over maybe even the internet, and some receiver wants to receive it and act upon it. So those two usually do not share the same lifecycle. They're deployed independently, configured, set up. Maybe even they are run by different organizations. And all this needs alignment and clarity on the contract. So what's the structure of the data inside, things like this. And of course, the messages that contain the events need to be routed accordingly so that all the receivers also get those messages. Serialization, deserialization of data, all this are challenges when you send those events over the network. And that's where the CloudEvents come to the rescue. If we get back to this abstract idea of an occurrence, I hope you can see already the next picture because I see a mouse pointer. Okay, so I hope now it works. If we get back to this abstract idea of an occurrence and try to describe a bit more what aspects could be described here. So first of all, there's this frame around all this. This frame around all this that could be seen as the context of the occurrence. That might be a service, a tenant, a system process, depending really on the domain in which you look at this. And this is what we usually refer to as the source of the event, the context of the occurrence. The occurrence as such also has a type. I mentioned already a few in the examples, like a button clicked or order created, order approved. Those would typically be event types. Identifiers, unique identifiers for an event are also important if you want to, for example, deduplicate events. That's then the consistency challenge I mentioned before. Timestamps are also, I mean, you want to know when something happened. That's a generically describable thing. And the subject field could be used to point at the subject to contain something like an identifier for the subject. In SAP case, usually a business object. And in the middle, then we have the old and the new state. That then is really very domain specific. So in our case, then the business logic. Here in the cloud event, we keep out of this. We just look at the envelope of all this. And for this state, we just allow to describe the schema this adheres to, and maybe also the content type, for example, JSON or Avro or whatever you. But it could also be it could also be an image file or a PNG, whatever. So that's really doesn't matter from the cloud events perspective. I hope. Here we go. So one example from the SAP world is SAP subscription billing, one SAP application. And I took actually that example from the Business Accelerator Hub, where you can find descriptions of all those events that get published by SAP applications. And in this case here, the occurrence is that a subscription billing gets deleted. And the interesting part here is maybe also the source, because that's something we defined for our case at SAP specifically. The first segment is this US 10 in this case, so one of the BTP regions that are available. In the middle, you have the namespace of the application. In this case, it's subscription billing.sb. And the last segment is the identifier of the instance of the application. So in this case, of a cloud application, I guess it's the tenant ID. We have an event type that contains, again, a namespace of that application, but also the name of the business object and what happened to it. And then in theory, there could also be multiple versions of that event type, but that happens very rarely, as far as I know. The subject points to the subscription that actually gets deleted. And ID is a UUID, time is a made-up time. You see that this one is even pointing to the future. Sequence is interesting because it's not a core attribute of cloud events. It's actually one of those we suggest as an extension in cloud events. So something you may use, but that is not part of the core specification. And it's used to even make clear the order in which events occur. So if another event then would have the sequence 1, then you would see that it's happened before this one. The data content type here is JSON. So the business part of this event is encoded in JSON. You see that it's almost the same data that is already somehow contained in there. But the difference is that this is specific for the application subscription billing, and they have other events where there's much more information in data. While the context, the event context that is marked up here, the cloud event part is generic, and those attributes are always there, and can then also be generically used by infrastructure components, like, for example, the SAP Event Broker, that use those attributes for routing. And they don't have to know the business logic behind it. Unfortunately, changing the pages is a bit slow. Okay, here we go. So sending events over the wire requires that you use some protocol. I here used the example of HTTP because I think it's one of the most widely spread protocols, even though it's not that ideal for messaging purposes. But nevertheless, so we have so-called modes in Cloud Events. And here I show the binary and the structured mode. On the left-hand side, the binary mode shows how the Cloud Event attributes that are shown here are put into the header. So they are all header attributes of the HTTP request. Therefore, they get this prefix CE- so that they don't collide with other header attributes in HTTP and do not interfere with existing infrastructure like web proxies, for example. And it's called binary mode because the actual payload is just taken as is and put into the body. And on the other side, then there is the structured mode, where we have JSON. In this case here, we have different formats that can be used for structured modes. JSON again is very widely spread, but there are is also Avro and protobuf. And here you see that the Cloud Event attributes and the business data, they are put together into one single data structure, JSON structure here, and that's the difference. You see also that the content type of the HTTP message is now Cloud Events plus JSON. So it's making clear that the body of the message contains a complete Cloud Event, while the content type of the payload is now called data content type and is actually shown here. Yeah, so that's the difference between those two modes. Protocols and formats. So let's have a look. Protocol bindings, I guess by now it's clear. It's meant to describe how Cloud Events can be transmitted using a given protocol. And we have quite a few bindings, AMQP, MQTT in various versions, NATS, HTTP, Kafka. I might even forget a few. On the other hand, there are those modes, and not all modes are relevant for all protocols. But the third one I didn't show yet is batched. That is quite similar to structured. I think it's so far as I know, it's just used in HTTP. You could then put multiple events into this JSON structure or whatever you use as a format and send them over a single HTTP message. So that's the idea of batched. I mentioned that we have those three formats, JSON, Avro, and Proto, but we have also draft specifications that are not finalized yet. For other formats, there's even one for XML in the draft. So the benefits of all this, I mentioned it several times. You have the separation of this event abstraction from business logic. That makes it quite interesting. That's also for us quite helpful because of this, we can nicely describe the events on the Business Accelerator Hub independent from the protocols that are used. Because actually, in practice, some of those applications that are shown there use HTTP for publishing these events internally, but others might use AMQP, for example. And this contract of how are the attributes of the events used, of the Cloud Events used, is independent from those protocols. Also, how you consume them might differ from what product you use to consume them. And another thing is the separation. I sometimes see it as a bit similar to what you have in some programming languages with generics. For example, in Java, you could think of this expression Cloud Event and then with this type pointing to your specific business logic, your event type. But you always have this same behavior around it where you can access those attributes, for example, or access the schema, things like this. It's infrastructure agnostic, so you don't have to look at, you don't have to replace all your proxies or existing message brokers, at least for those where the protocol is supported, like for example, AMQP. You can even mix Cloud Events with normal messaging or plain HTTP and things like this. That was one of the important design goals also for Cloud Events. And it's supported by many vendors, not just SAP these days. We have in the ecosystem, in the community, we have SDKs and several products that SAP also supported. There will be one of the sessions I point you to will be about how events are produced in ABAP and then consumed or routed through advanced event mesh, for example. I've seen also a trend to standardization of events. So there are some publicly specified events, like there's one set for continuous delivery, CD events. They refer to cloud events. I've seen another public specification which is about product carbon footprint, I think. So that's also what is facilitated by this separation of business and technology in principle. So that was this part about cloud events. So we have, as I said, cloud events define this common metadata for events and facilitate the delivery of events this way. I don't know, have there been questions already?
No, there are no questions at the moment on the chat.
Okay.
But yeah, I do encourage everyone to drop their questions. I've been sharing some links for the specification, and you were talking about protocol binding, so I share those as well. But no questions so far. Yeah.
Okay. Then I'll now continue with this other part you can see here, xRegistry. It is actually also an initiative by the Cloud Events project, even though we now have our own logo for this. We started looking at messages, schemas, and endpoints initially, but arrived at something much more generic and abstract. But the discovery story was, I think, more or less what guided us there. I'll start with this generic part. So xRegistry is about having a registry for all kinds of metadata artifacts, I would say, or documents even. And we use it for certain document types around events and schemas, but you could take anything, like also open API documents or I don't know, Helm charts, whatever you have in mind, essentially, if you and it's extensible. That's why we made this xRegistry. You can add your own metadata attributes on each level, group, resource, or version. And one interesting aspect is also that we aim at having a single file, a static folder structure, or a full-blown registry server, and to enable all these levels, so that you could, as part of your project on GitHub, have a single file with a registry, but you could also run your own registry that really offers an API where you can search and filter and all these things. And as I said, we looked at different things. Message definitions are stored in message groups. Actually, it's intentional that we say message here, not event, because it can also be used for plain messages, plain AMQP, HTTP messages, whatever. But one important case here is, of course, that you use an envelope for cloud events, and that's also where I have another slide later on. But a special case of this message group, if you not just define an abstract group of messages that might be used somewhere or something like this, but you want to point to a specific endpoint that makes use or supports these messages, then you can have the endpoint, which is, you could say, a specialization of message group even. And the third thing we have here is the schema group, where you can store a group of schema documents inside. And each schema can also be versioned. So that's where we use this versioning mechanism also. And schemas play an important role. There has been this schema attribute in cloud events, and it's also important for the API space, and schema is really everywhere. So that's why we also have the schema registry part in here. A short explanation on this abstract term endpoint. I think it's a nice abstract model to describe, to have a common denominator over all those different messaging technologies that are around. We differentiate three different kinds of endpoints. On this slide, you can see producer and consumer endpoint. On the left-hand side, there's the consumer endpoint. And yes, the producer offers that consumer endpoint, but it offers them for consumers. So that's the point. Sometimes this model is also referred to as the pull model, because the consumer now opens up a connection to the producer, and initiates that and gets then this flow of events routed into the into itself essentially. That's typical for message brokers, but you could also do it when you are polling over HTTP. The other approach is then the push model, where you have a producer endpoint, and a producer would like to discover where to send events. And this is now on the right-hand side. The producer in this case has found an existing producer endpoint and then can initiate the connection and send the events over. That's one important example, I guess, that many people know is the HTTP webhook here. A third type of endpoints we look at is the subscriber endpoint. Here, that is a bit specific to the CloudEvents project because we have this specification for a subscription API. You can use this subscriber endpoint to subscribe your producer endpoint to a producer that then sends the subscribed event to this endpoint you're providing during subscription. Okay. I said that you can describe any kind of message with what we have so far in xRegistry, but that the envelope that is used is of course important, as we are still also the CloudEvent project. And here you see one way is to have everything in one definition. On top you see this protocol HTTP and envelope CloudEvents. But you could also think of the other case where you just describe the envelope in one message group, for example, and then you create endpoints or other message groups that then contain the protocol specifics and point to this envelope. So in this case, then you could then make use of this property of CloudEvents, that it is protocol independent in the sense that the attributes are protocol independent, and then bind it to providers that make use of specific protocols. More information. So the first one, this is the SAP side. CloudEvents at SAP. So Antonio has written a nice blog about CloudEvents at SAP. So that's why I mentioned it here. And also in the coming weeks, there will be several sessions from my colleagues about CloudEvents, not only about CloudEvents, but they will play some role in those sessions. And so the business event, the SAP Event Broker I mentioned already, and how this how you can write CAP applications to combine the two is one session. We have this ABAP session I mentioned already as well. So here it's about routing events from ABAP systems in advanced event mesh, and those events are also cloud events. And you can then also with Carsten, you can discover event sources that can be used together with advanced event mesh, and SAP event sources then are also cloud event sources. And finally, there's this session about using events from S4HANA in SAP Build. And yes, those events from S4HANA are again cloud events. And you will see that then also in the session. On the other hand, there's the community. So that's again my community hat I put on. You're also welcome to join the CNCF community. We have those GitHub repositories. GitHub is our main way of interaction, actually, because we even discuss issues that are created there, pull requests that are created there in our weekly calls. If you just want to chime in and listen in, or maybe you have something you want to discuss, you're also welcome in the calls. It's a very welcoming community, I can say. People are very, very nice there. There's also Slack if you like this chat alternative. CNCF also maintain their own Slack workspace. And with this, I'm finished. I don't know if I have more time or if there are questions.
There are a couple of questions that I've been able to address, but you can address them as well. I would say so. One of the questions was for all S4HANA business events, are they just regular events or are they already cloud events? The events that are generated by S4HANA.
They are cloud events. That's we several years ago we created this internal guideline about how events are created, and those events are all cloud events. I can even show this. So this is not S4. This is my example from SAP subscription billing. Here you can see it's a bit hidden, I have to admit, but still, if you look at headers, you see again the cloud event attributes, and that I think is also the case for S4HANA. So you can also explore all the events here. I don't know, maybe I can look for something like my old
Yeah, so
favorite one, the business partner.
yeah, business partner, you'll be able to find, yeah.
So if you look at the reference here, that's the same view I had there before. Headers, and you see again source, type, time, spec version. So these are again the cloud event attributes.
Yeah, exactly. So yeah, you in the Business Accelerator Hub, you will obviously find all the events for the different SAP products that generate, and all of them are cloud events. There was one question, maybe you know this, I don't know more information about this, but moving forward, how about products like SuccessFactors, Concur, Fieldglass, or other products? Will they have events as well?
I can't really answer this question.
Yes, it's a tricky one. It's a tricky
Yeah.
one. That's something that I generally ask also like the different product owners or product managers from the different teams because yeah, there's always an interest, right? Instead of calling an API to see if something has changed, why not having the product actually informing you or connecting to some form of a middleware to let others who are interested on changes in that particular system, that something has happened. Yeah, unfortunately, I don't have any more details. I know that SuccessFactors, you're able to configure events, so when something happens, but they are not really cloud events compliant. They're able to post something to an HTTP endpoint, for example, and you're able to configure it so that maybe send it to an event middleware like advanced event mesh, right? But then
Yeah.
it will not be cloud events compliant. It doesn't follow the specification. It does generate like a JSON payload, for example, for you to use, but yeah, it doesn't follow the cloud events specification, unfortunately, in that case. Yeah, those are all the questions that we have at the moment. Now, I have one question, just out of curiosity. When you were showing xRegistry and how, for example, a consumer can end up sort of informing a producer, right? Like, or checking, for example, the events that a producer produces, right? But then in a way, and then for example, and then I'm able to subscribe via that mechanism. But then in a way, it's like that's sort of creates this. My question is the following: is there an event middleware somewhere in that picture? Just because, like, if I see it like that, as you explain it, like, it feels to me like you're basically end up creating like a direct integration, like a point-to-point integration, because in the end, the producer will end up communicating directly with me, right? Like we end up sort of losing the decoupling and the asynchronous aspect of events, or maybe I'm missing something.
Which one is it? This one, or was it
No,
the one with the
the previous one, like for example,
this
this
one?
one, the subscribe. Yeah, exactly.
Okay. Yes. Okay. So the producer is not okay. That's maybe not the exact term actually. Producer is sometimes used as a shorthand for someone sending that event, but it might actually also be a middleware, message-oriented middleware, like a
Okay.
yeah, actually event broker, for example, SAP event broker could, I
Mhm.
mean, they currently don't have the subscription API, but in principle it works for them exactly this way, that you
Mhm.
subscribe applications to events and then they are routed according to cloud event specifications. So the idea of this whole middle endpoint concept is actually that you can combine them. You can build topologies of these. Your consumer here could also be again a producer to the other side, and then you could have other endpoints there. That's also what happens if you have something like a queuing system. So you might attract something from a webhook, an HTTP endpoint that pushes data, and if you have other consumers that would like to consume the data at their pace, they would put something like a queuing system in the middle, and then they would subscribe the queuing system to this webhook to queue the messages, and they themselves would then connect to the consumer endpoint of that queuing system. So that's the idea, and that's why we introduced these endpoint types, because we think we can describe a lot of the concepts that are out there for messaging and eventing.
Okay, now it's clear to me. I was just thinking about the producer as being an application itself, like a system, and not that it could that producer can actually be some form of event middleware, right? Where it does make sense. Like if you're there communicating with the middleware, then yeah, you are then you're sort of you don't really know who the source system is, and there's the decoupling aspect to it and the asynchronous bit. Yeah, we don't really have any additional questions. So some very nice comments here. Nice concept and great session. Thanks for sharing. Thank you for a great session. So yeah, I think we can end up wrapping up. So first of all, thank you, Klaus, for sharing your knowledge and expertise in this session. I would say, yeah, keep an eye on CloudEvents, which is powering a lot of the different events that we're getting from the different SAP applications, right? That produce events. There, as Klaus correctly highlighted, all the sessions, and you're actually missing one session there in that screenshot.
Oh.
There's another one for enterprise automation, which in the background, what they're going to do is basically an S/4HANA and an advanced event mesh communicating with each other, and the message that's flowing from between those two systems is a CloudEvents message. So, so yeah, they're everywhere, I would say. Although we don't really talk much about them, they are basically what are powering the event-driven architectures in the SAP world, right? So yeah, thank you. And I also want to thank the viewer. Thank you for joining the live event, or maybe the recording, which can be in a few hours, or in a month time, or even in a year time. This session is obviously relevant still, like for posterity, right? Like for the future. So, and a quick reminder to everyone: there is plenty for everyone to learn during the Toyfest. So make sure to check out all the sessions that are part of the event, and that's it. Thank you.
Thank you.
Yeah, bye.
Bye.